Welcome to my presentation. In this presentation, we shall see how to add matrices. So let's define matrix addition. How do we define that? If A is a matrix which has elements Aij, and if B is an other matrix which has elements Bij, and these matrices are of size m by n, then we can add these two matrices as follows. Matrix A plus matrix B is going to be equal to Aij plus Bij. We can add the corresponding elements of those matrices. Let's explain this with some simple examples. Let me say we have an example of this type. We want to add these two matrices. If matrix A has elements 1, 2, 3, 4, I'm just taking a very simple example, and if B is another matrix wherein the elements are 5, 6, 7, 8, like that, when we add these two matrices, this is what is going to come out. Matrix A plus matrix B is going to be equal to, we can write this one out as follows. 1, 2, 3, 4, this is matrix A, and we're going to add matrix B to this, 5, 6, 7, 8, enclosed in these big brackets like that. In here, the way we do this is we're going to add the corresponding elements in those respective rows and columns. So first row, first column of the first matrix will add to first row, first column of the second matrix like this. 1 plus 5, and then 2 plus 6, and then 3 plus 7, and then 4 plus 8. We can come back and then simplify this. We've added this row, this one here is first row, first column. This one here is first row, second column. This one here is second row, first column. This one here is second row, second column. So if you look at this, we can simplify them right here. 1 plus 5 is 6, 2 plus 6 is 8, 3 plus 7 is 10, and then 4 plus 8 is 12. So therefore, when we added these two matrices, the result is going to be as follows: 6, 8, 10, and 12. When we added these two matrices, this is the result we got. This is the result we got. Okay. So let us look at another example. Let's say in this example, if we have matrix A as equal to 1, 2, 3, 4, 5, 6, like that, and then if B is another matrix, and then if this one has elements of this nature, negative 3, negative 2, 1, negative 5, 4, and 3, like that, and then if we were to add these two matrices, matrix A plus matrix B, we can add the corresponding elements of those matrix A and matrix B. So in here, since we are going to add A plus B, we can write this one out as 1 plus minus 3, 1 plus minus 3, like that, 2 plus minus 2, like that, 3 plus 1, and then 4 plus minus 5, and then 5 plus 4, and then 6 plus 3. We'll come back and then simplify this. So we can write this as 1 minus 3 is negative 2, 2 minus 2 is 0, 3 plus 1 is 4, 4 minus 5 is negative 1, 5 plus 4 is 9, 6 plus 3 is 9. So therefore, when we added these two matrices, the resulting matrix is also a matrix like that, and then it will pretty much follow the size of the matrix. The size of the matrix. In here, if you look at this matrix here, we have 3 rows and 2 columns. 3 rows and 2 columns. The size of this matrix is 3 by 2. The size of matrix P is also 3 by 2. We can add when the sizes are the same, that is when the number of rows is and the number of columns is equal, only then we can add those matrices. If the number of rows is not equal to the number of rows in the second matrix, then we cannot add those matrices. Okay. And one other observation we can make from this here is that when we add two matrices, or when we subtract two matrices, whatever size we have, the resulting matrix is also going to have the similar size. For example, here A was a 3 by 2 matrix, B was a 3 by 2 matrix, and when we added these two matrices, the size came out as 3 rows and 2 columns matrix. Okay, so these are some of the examples of matrix addition. In my next presentation, we shall see how to do scalar multiplication of matrices.